I just learned something terrifying about Python that I wish I knew years ago. The only reason I found out was because Google's new Gemini CLI has this massive context window. There's a function in Python standard library that can give attackers remote code execution onto your servers. It has been documented over a decade, maybe I think it's Python 3.4, but buried so deep in security warnings that most developers, including me, had no idea it existed. This is where AI code analysis is getting really scary good. If you're ever wondering whether AI can actually teach us about security vulnerabilities, which we never knew, this video is going to blow your mind. So before we talk more about how Gemini helped me understand the vulnerability, which is already there, obviously, I would like to show you a demo how things would actually work out in real life. So I'll be showing you how attacker actually attacks a server and how the attack, once it's actually successful, allows the attacker to run arbitrary codes in the server itself, or probably call an external service and pass on the information. So let's jump to the demo first. Cool. So let's start with the demo. And in the demo, I'll be running the simulation in 3 different terminals. One is obviously the attacker who's actually executing the script. Second is the vulnerable server who's getting attacked. And third is where I'll be running the listening server, which actually waits for or like listens for inputs from different servers, right? So where the attacker is actually making the vulnerable server to send some code to the server, the listening server, and the listening server is actually listing the information what is actually getting passed from the attacked server. So in the first terminal, let me start the client. So I'll execute the client code at last. Let me start the listening server first on terminal 3. So Python 3 listening server. So listening server is actually listening on port 4444. And in the middle, let me start the server. So the vulnerable server. Cool. So in the vulnerable server, I've already added some logs just to see how the traffic is actually going in. Okay, so let's start the attacking server script. So once I invoke this code, you can see that the malicious payload is actually sent, and you can see a couple of messages, and even the error trace is also shown here. Then on the third side, on the third terminal, you can actually see that we have actually received a message called pound. This message is actually sent from the vulnerable server. So we go in detail once I talk about the code. So here basically the attacking server is actually sending a script to the vulnerable server, and the vulnerable server is actually executing that without any validations. And that validation, that the script is actually sending a code, or like it's actually executing a payload, and that is actually sending a message to us in the listening server. Basically, in a real world, probably you could actually send some information, probably a password string or like a password file to the arbitrary server. So in this case, I'm just sending a message called pond here. Cool. So yeah, obviously, I've used Gemini here. I wanted to explore how Gemini CLI is actually working, and yeah, Gemini CLI has actually helped me understand the bug which is already there, obviously, and we'll talk why this bug is not even closed by the Python developers. And if you have not installed Gemini CLI, this is how it would look when you start the command line interface. So here, I've actually asked Gemini to actually go through the Python code base, right? So I've actually downloaded this CPython source code to my local repository, and I've asked Gemini to actually look through the source code and find vulnerabilities within the code base. So it has actually gone through, it has done some basic regex search. What I understand from thing is that it's actually understanding the entire file base. Probably if for searching the thing, it's actually running some regex, and it's actually trying to analyze couple of commonly seen vulnerabilities, like let's say in this case eval, execution, all these things, right? Probably if there is any OS dot some system variables getting invoked. So those kind of things are actually getting searched. It has actually found a couple of places it has actually seen this eval function getting executed, and based on that, it actually told me that, hey Gio, there seems to be a potential vulnerability. So that's what you can see here, right? It's saying that there's some potential vulnerabilities, and actually going through different things, and from that it has actually found actually a couple of vulnerabilities. But for this demo, let's keep it simple to just one. It started to give me a Gemini CLI. Obviously, Gemini LLM is actually trying to give me or like show me where it is actually happening, right? What is actually causing this issue. Slowly, we actually went to just one single vulnerability where it is actually trying to understand how the what you call the config file or the logging is actually handled by the server. Right, in this case is actually the configuration is actually getting passed to the server, and the server is trying to execute it as a dictionary, thinking that is a dictionary. If if there is any problem in the payload, in the dictionary payload, it actually falls back to the .ini file, and the .ini file is where things all happening, right? In that you can actually pass a Python arbitrary code itself, which gets executed, I'll actually show the code which is actually getting executed, because it's like eval and the parameter, right? Eval and the class is actually getting called. So that's how it's actually getting executed. So I did actually go back and forth, back and forth. I actually asked Gemini to build some POC so that I can understand how things are actually working, right? So it gave me a lot of suggestion. It has actually shown me how the POC is actually working, because it gave me two different Python scripts. One is obviously the vulnerable server, and then it gave me the client side of things. And we went back and forth, understanding how things work, right? Most of the suggestion that given by Gemini wasn't working at the initial stage, but yeah, with all the back and forth conversations, we actually we ended up, we in sense, me and Gemini, we ended up having a working POCs. I'll be actually linking the POC in the POC code base in the GitHub repo, so that you can actually go through. So you can just see how I see, instead of talking about the vulnerabilities, because vulnerabilities all there for the last 10 years, I think, because it was seen from Python 3.4. I think it was Python 3.3 or something. It was actually uh, what you call considered by the developers in Python 3.4. Considered in the sense they understood that there is a problem, and they actually reported, or they've actually added to the security what you call good things that you should need to follow when you develop things, right? Those kind of listing they've actually implemented, or they have actually listed it there. But why they haven't removed, or why they haven't added a rule saying that okay, you shouldn't use this method, is because they wanted to maintain the backward compatibility. We'll actually talk that more about that in the presentation. So yeah, so coming back to the code thing, right? So we actually went back and forth, and actually CLI, or the Gemini CLI itself told me that I need to actually report this to the Python developers. In the first sense, I thought that okay, this isn't real, right? Because all of a sudden Gemini is able to find the vulnerabilities in the system. Um, what if I actually went in and spent some time, probably a couple of days into this thing? Probably Gemini could actually help me understand, or find the hidden vulnerabilities which we never knew, right? Which even the Python developers, the initial developers, also wouldn't have thought about. So this is what I want to emphasize here. So in within a couple of hours, I could actually find this thing. Obviously, it is already there, but the thing is that I'm trying to tell if I'm actually spending a lot of time into this. Probably not Python, probably different packages or other open source libraries. We could actually understand, or we could actually find the vulnerabilities which are actually hidden. So that's the potential that I'm trying to reveal here. You can actually literally see, once I close the session, you can actually see how much time I have actually spent on this thing, right? It's literally about 6 hours I actually spent. It's not probably 6 hours. The CLI was actually running for 6 hours, but yeah, probably 3-4 hours is what I actually spent on this thing, just to understand how the Gemini CLI is actually working, right? In this, see, I've actually spent, oh, in this case, it's around what? 17 million. Oh god. And output tokens is this much, and total token consumption is this. So this is the actual statistic, and 75 times I've actually taken turns back and forth conversations. So yeah, so for people who haven't seen what is Google Gemini, let me open the page, right? So yeah, so this is the official page of Google releasing the Gemini CLI here. So Gemini CLI, which I actually found interesting, is the amount of what you call the quota that they've actually given for free usage. So basically, you just install the CLI through the terminal itself. The basic instructions actually given in their page, right? Go have this npm install, and then obviously it'll ask, the next page would be the login page, right, where you can actually just hit enter, because there are a couple of options that they actually provide. Hit enter, and it actually asks you to log in with your Google account, or you can actually even provide your the credentials if you have a different plan. So here it's about 60 model requests per minute, and obviously 1K model requests per day. You can actually do a lot of things. I just explored a couple of things, right? You can actually have a memory session also. You can actually save to memory. You can actually have a web search, and there are a lot of features that even I'm yet to explore. The first day of using Gemini CLI is where I asked it to understand the Python code base and explore. Okay, so the experiment what I ran is asking Gemini CLI to go through the Python code base and understand vulnerabilities, right? So what I expected is, obviously, if there is any issues with the code, and if there is any pattern that I need to understand, and obviously I didn't expect anything serious to come out, right? But what I got is obviously the RCE, right? Remote code execution vulnerability was actually presented. Okay, so more of the vulnerability, right? So here basically, just to give a gist, it's usually what you're seeing is there would be some places where you would be sending configurations to different microservices, right? Let's say you are having a multi microservice architecture and you want to send one configuration to other, or you are actually changing the config. Let's say your team wants to change the debug log to different type of log, right? Info log or something, warning or error logs, right, in production. So if you want to keep switching, if you want to switch something in the production, let's say you want to change on the go the configuration file, you can actually send, there is something called logging.config.listen, where you can actually send the configuration and it will actually change the logging configuration. So probably, I mean, that's one of the examples. So what happens here is it expects to be in a JSON file, the payload to be in JSON. But if you're sending something different, or if you're sending a payload that is having some issues, it's not in proper JSON format, it actually falls back to the default INI format itself. So it actually tries to parse the INI format and actually executes. It actually tries to evaluate what is inside that, and that is where all the vulnerabilities, or that's where the arbitrary code is actually getting executed. So the real world impact. So internal microservice, as I said, it's if you're having an internal microservice and the operation team wants to send dynamic logs, right? An attacker gains access to the internal network, probably through phishing or something. He scans for the open port and obviously send malicious INI configuration and gets remote code execution. Or you can actually send some code which actually shuts down the service. I did ask Gemini to find the CVSS score also, because that is actually based on a lot of numbers, right? And it actually says it's 9.8. So you would be wondering why no one is actually patched this issue, because I have run this code on Python 3.10, right? 3.10 is the version which I'm actually running. This code base what I downloaded from GitHub is actually having the latest, that is Python 3.13. That's the latest thing. Still the vulnerabilities are there. So why it's not patched is something that I'll reveal a couple of slides down. Okay, in the live demo, so this is what is happening. So when you send the payload, right? Previously I told the INI file. The INI file is actually structured in such a way that it actually gets this arbitrary class is getting executed. So attacker initiates the listening server, and the vulnerable server is actually sending the data back to the attacker's server. So basically, this payload can be changed to whatever he wants. Probably he can have a what you call reverse shell, or he can actually send what you call credentials from the servers, right? Probably if you're having an internal, I mean, some model API key, something like that, right? You can actually send that information to the attacker servers. So the big question, why hasn't this been fixed? So Python team already knows this thing. So what I understood is that Python developers always wants the backward compatibility to be always available. And since this is, I mean, this vulnerability is in the code base, I mean, we can't say it as a vulnerability, because it's up to the developers to understand, or like during their implementation needs to know that, okay, this is actually a problem, and they need to actually have a proper validation before they actually execute a code. So in this case, once the vulnerabilities was actually revealed, right, they actually added a verification parameter where you can actually send a function, or like the verification, what you call the payload should actually go through a function which actually inspects the payload, and obviously only after that we should actually execute, instead of literally taking whatever is got and then executing, right? There is no fix. Probably the fix is not needed, but I would suggest they would make some what you call warnings message or something, right? When you execute this code, there is no warning, there is no message to the developer saying that, okay, you shouldn't do this thing. Developer has to go and understand from outside sources, right? Probably from the Python website itself, or security what you call listing there, they'll have to understand, okay, this is actually a problem and I need to actually verify this thing. And with all the recent releases of Python, there are different ways how we can actually send the configurations, right? It can be through different ways, like environment variable or something else, a different way. Probably it's an API endpoint itself. Okay, so why it persists? Obviously, for backward compatibility, which I already mentioned, and internal network feels safe, right? When we talk about internal network, we all think that, okay, no one is able to access the network, so probably it's safe. But there are a lot of ways we can actually bypass that. Uh, so yeah, people common mindset is obviously internet network is obviously safe and we need not worry about it. But yeah, who knows what happens. And the main risk is obviously developers don't know. Even I didn't know that this was actually there. And recently I came to know that there is a separate page dedicated where all the things are already listed, but it's not even clearly talk to others, because right now, since all this machine learning boom has actually happened, people are getting into Python and we're not sure what is already there, and which is not even fixed properly. I don't say fixed properly, but it's left to the developers to decide how they want it. Even though Gemini is having a huge context window, it's actually based on regex, right? So sometimes it goes through the code base. Sometimes it feels that if it's too much, it'll actually go through basic checks, right? Like eval functions are getting scanned through the entire code base, those kind of things. But obviously, what we can say is once the context window is huge, we can actually put a lot of information and ask it to go analyze one by one and find a pattern in the system, and obviously understand the correlation between different files, and that actually helps us a lot in the code analysis itself. So cross-file analysis, tracing data flows everywhere, and pattern recognition, finding the suitable vulnerability chain, fresh perspective, no assumptions about safe internal APIs. Okay, the future is AI will find bugs humans and tools miss, right? Obviously, but we can't expect always AI to do that. We'll have to give some prompts and guide it accordingly where it needs to think or let go about. Legacy code bases have hidden time bombs, obviously, as things releases probably for just for backward compatibility, the hit might be still there inside the system. And we need to rethink what is audited versus secure, right? Even though we just scan through the code, we need to probably run some simulations to understand what it is actually doing, right? Probably seeing a code, we would think that okay, this is all good, but running simulations, running different types of tests would actually reveal a lot of things. So how to protect us? Obviously, the reason is we need to understand the code in detail. We need to understand code in sense what we are actually implementing. If we see that there is some verification, something is actually given by the developers, we need to implement that. We shouldn't just go with whatever is actually easier for us, right? We need to understand what is actually that function is actually doing, and based on that, we need to configure different things. That's the only way I understand how things can be solved. So key takeaways is obviously AI tools are getting scary good, and finding complex bugs is actually very easy now. 10-plus-year-old vulnerability is still lurking around, even though it's not a vulnerability per se, since it's in the code base and it's left to the developers, it's still there. And if you by chance configure it in the wrong way, it might be used in a different way by attackers, obviously. Backward compatibility can be a security nightmare. Yeah, Python is obviously used by millions of users, and obviously we need to make sure that things are not breaking. So yeah, we need to maintain compatibility, but still, one thing I would suggest is we need to give some warnings when this actually getting invoked. Right, that function is actually getting invoked. If it is not used properly, we should actually build some tools to guide the developers. Internal networks aren't safe from sophisticated attacks. Obviously, we can't say what is in our network, right? Who knows? Document is not equal to fixes. Obviously, if things are documented, doesn't mean it is fixed. Yeah, it should be properly used, and there should be a guiding factor for all these things. I'll be linking the code in the description, so probably you can actually look at this. So yeah, more than talking about the vulnerability, I wanted to express my what do you call my experience using Gemini CLI. It's very, very, very powerful. Obviously, Claude Code is also doing the same thing, but Gemini, I feel little more comfortable. Like it's having, obviously the context window makes more sense, but there are a lot of other features that Claude Code is actually lagging. Probably I'll do a separate video on this, the comparison between Claude and Claude CLI, Claude Code versus Gemini CLI. Cool then, thanks for watching. If you think this video is great, if you think I need to create more videos like this, which actually talks in depth, understand the core concept, build some POCs, those kind of things, please reach out to me. Probably add some comments if you think there are other videos that you feel I should actually do. Also follow me on LinkedIn and ping me if you feel I can actually contribute to build something great for the world. So thanks for watching. We'll probably see you in the next video.